And actually, I'm going to hand it over to Sandra first. She's going to provide the update on Atlas 15 since we just released the Atlas 15 pilot at the end of September. And then after she's done and fielding maybe some of those questions, we'll jump into a quick overview of the Office of Water Prediction and some of the stuff that we're doing to support new real-time flood predictions and forecasts. So Sandra, take it away.
Okay, hi everyone. I'm just trying to share my screen and share Audible as well, because I want to play some of the video, but it seems that I can do one or the other. So I'll first present and then I'll do share Audible when I'm sharing the video. Okay, everyone can see my screen?
Yep.
Yep.
Okay, perfect. So thank you everyone for inviting us to present and showcase the Atlas 15 pilot information. Just a little bit for a background. NOAA has been the trusted source of precipitation frequency data, and this data has been integrated into federal, state, and local standards for planning and designing civil engineering infrastructure. For the past 2 decades, we continuously refine these estimates through the NOAA Atlas 14 regional studies, which were funded by the states and other users on a cost reimbursable basis. I want to mention something that on September 19, 2024, so a month and a half ago, we published the NOAA Atlas 14 Volume 12 data over state of Montana, Idaho, and Wyoming. And that data supersedes estimates from NOAA Atlas 2 that were published back in 1970s. So we have additional 50 years of data with this release. As illustrated on a map in the middle, you can see that all the states have been updated with NOAA Atlas 14 except Oregon and Washington. And these Oregon and Washington states still rely on older NOAA Atlas 2 data. Thanks to ongoing state funding, we're currently developing volume 13 data sets, also for using NOAA Atlas 14 approach. And this area has been impacted by Hurricane Helene. And with this volume, when completed, we'll replace the data from our second NOAA Atlas 14 regional study, which was published 2 decades ago. So our current NOAA Atlas 14 standard, there are 2 significant gaps that we're trying to address with our next revision, which is NOAA Atlas 15. And due to the funding mechanism and the way the funding was allocated in the past, we published the estimates in a piecemeal fashion over different regions, which led to boundary issues between the studies, and that also impacted our users that live in areas where watersheds cross state boundaries. The second gap is that NOAA Atlas 14 methodology assumes that climate is stationary in the statistical context, and that concept no longer holds true in the light of climate variability. With the bipartisan infrastructure law, we have received the first direct federal funding to update the precipitation frequency standard as a seamless spatial analysis, so we will not have a boundary issues over CONUS and OCONUS regions, and to account for climate trends. So today, I'll talk about NOAA Atlas 15 pilot project in Montana that was released on September 26th. Following the pilot, we are going to publish the final estimates over CONUS region in 2026, and we plan to go through the preliminary peer review process in 2025. And then for the OCONUS region, we plan to publish estimates in 2027 and go through the peer review process in 2026. With all NOAA Atlas 14 precipitation frequency data, we go through the public review process. This process is really a critical step in development where we integrate local knowledge of data, climate into federally developed data set, but also really help with adaptation efforts. So NOAA Atlas 15 pilot was released on September 26 and is available for review. The purpose of the pilot is to provide a first look into structure of NOAA Atlas 15 data in order to gather early feedback that will inform our development process and dissemination strategy in order to shape the final version of NOAA Atlas 15. We often get asked why Montana. So the pilot estimates are only provided for Montana state. And Montana was chosen for this pilot because it has a diverse terrain, which provides excellent testing ground for the new methodology and data set. But more importantly, we also had high quality data from recently published NOAA Atlas 14 Volume 12 study, which allows us to make a direct comparison between new methodology of Atlas 15 and our legacy methodology of NOAA Atlas 14. So the pilot data is presented in two volumes. Volume 1 that is based on historical data for the year of 2023, and then Volume 2 data that is developed by applying adjustment factors, which represent relative future changes calculated from downscale climate models. And those adjustment factors were multiplied to Volume 1 to get Volume 2 estimates. And then furthermore, Volume 2 data are provided for future periods in two distinct frameworks, scenario period framework and global warming framework that you will see later on. The final Atlas 15 data will have the same range of durations and exceedance probabilities that are found in NOAA Atlas 14, from 5 minutes to 60 days and up to 0.1% annual exceedance probabilities. But for the pilot, estimates cover only a subset of storm durations and probabilities from 1 hour to 10 days and up to 1%. Okay, so I have here a pre-recorded video to demonstrate Atlas 15 pilot webpage. And this video is also accessible on the website via OWP YouTube channel, so you can refer to it later on if needed. I'll stop presenting, I'll share it again so I can share my video recording. I just want to mention that usually when we share the video recording through the Zoom, it's usually 20% less volume, so you may need to increase the volume on your computer if you don't hear it really well.
Welcome to the NOAA Atlas 15 pilot webpage. This pilot study offers a first look at the structure of the NOAA Atlas 15 dataset over the state of Montana in order to collect early feedback on the data and web dissemination strategies. NOAA Atlas 15 will continue to be refined through 2026 and 2027, when estimates will be officially published. The release of NOAA Atlas 15 pilot data is intended for comparison and feedback purposes only, as it has not yet completed the peer review process. Detailed information on the development of NOAA Atlas 15 can be found on this page. To access the pilot webpage, please click here. The NOAA Atlas 15 pilot covers a subset of storm durations of 1 hour to 10 days and average annual exceedance probabilities of 50% to 1%, and is presented as two volumes. Volume 1 estimates are based on historical observations and provide estimates for the year 2023. Volume 2 estimates are developed by applying adjustment factors to the 2023 Volume 1 estimates and are presented for future time periods as part of two distinct frameworks, global warming level and emissions scenario. Under the title, you will see two maps. The left is a map of Volume 1, and the right is a map of Volume 2. Displayed on the map are the gridded estimates that can be selected below the maps. Users can change the base map to topography, satellite, dark or light modes. Opacity can be varied in order to see more of the base map through the estimates. For the pilot study, the time series default is the annual maximum series. Precipitation type defaults to depth, but intensity can also be chosen. The default units are in English, inches, but metric units in millimeters can also be selected. Both maps currently default to 50% annual exceedance probability and 60-minute duration. Users can change these options and both maps will update accordingly. Both maps are in sync and will zoom into the same location simultaneously. Users can zoom in and out of the location by using the plus, minus, and home buttons at the top right corner of the left map, or by using the cursor and pressing Control and using the mouse wheel to zoom in and out. Double-clicking the mouse button will target a new location and update the output of the table and chart below. The location search under the left map can also be used to type in a specific address, town or city, or latitude-longitude in decimal degrees, with a comma separating the latitude, which comes first, from the longitude as seen in this example. Also, above the Volume 1 map, on the right side is an option to select Show Stations, where stations used in the development of the precipitation frequency estimates can be displayed on the map. For the Volume 2 map on the right side, users can select whether they want to choose a scenario or global warming level by using the menus above the map. The default option is global warming level and 3 degrees Celsius. Global warming levels can be selected from 1.5 degrees through 5 degrees Celsius. When selecting the scenario option, a new tab will appear where you can select SSP 245 or SSP 585, and then the year can be selected decadally from 2030 through 2100. Below the map on the right side, you will find the precipitation frequency estimates for the selected duration specified above and for the subset of annual exceedance probabilities. For the pilot study, only the 90% confidence interval is available. An additional projection from the Volume 2 estimates within the selected framework has been added to the table as the last column on the right with the title text in purple. This additional projection will also be displayed in purple on the chart on the left. Below the map on the left-hand side is a chart of precipitation depth versus annual exceedance probability for the duration selected above. The green line represents the Volume 1 estimates, and the shaded area indicates the 90% confidence bounds. The blue line represents the selections chosen for the Volume 2 map, the default being global warming level 3 degrees Celsius. The purple line is the additional projection. Users also have the ability to toggle on and off the lines and confidence intervals on the chart using the legend. Just above the chart are tabs where the users can access other useful information. The Table tab provides estimates in tabular form. In the future, users will be able to toggle specific durations and annual exceedance probabilities for download. We would like your feedback on what format you would like to see the data provided. Clicking on the Compare button will bring up a pop-up window that has full tabular data for Volume 1, as well as selected global warming level or scenario selected for Volume 2. The global warming level or scenario can be changed in the pop-up window using the drop-down menu. For all feedback, please see the link "Click here" to provide feedback at the top of the page under the title. This will bring you to the feedback form. Users can go back to the NOAA Atlas 15 informational page by clicking on the link found here. There is also a link to the documentation found here. Thank you for your participation. We value your feedback and look forward to hearing from you.
Okay, so I'll continue with a few more slides. I just wanted to point out here that as it was mentioned in a video, we are seeking user input to understand how NOAA could evolve its existing approach with the pilot to deliver and disseminate NOAA Atlas 15 information nationwide in a way that maximizes its utility for communities and practitioners upon the final publication. I
Hey
want to make
Sandra, I'm gonna interject. Ever since you came back from the audio doing the video, it almost sounded like there was like really strong static. So let's maybe try. Sounds like it stopped. Thank goodness. Okay.
what's going on. Okay, sounds good. Okay, so I just wanted to mention that as we said at the beginning, the pilot data is really covering the state of Montana only for visualization purposes. We're looking to get a feedback for communities across the country. Slides are not showing. Is that still correct?
Yes, it is. It says double clicked enter screen mode.
Okay, let me. You can see it now?
Yes, thank you.
Okay, perfect, thank you. Okay, so for the, as we mentioned, we have the pilot studies only for the state of Montana, but we're looking the feedback from communities, not just in Montana region, but in over CONUS and OCONUS region to get a feedback on not just the data and the structure of the data, but also NOAA dissemination strategy. So we're asking the American Society of Civil Engineering community to share and provide feedback to the pilot data to ensure that their communities and practitioners need this need the information that is served is what they need, particularly for when we release the final estimates. We encourage everyone to provide feedback through the feedback survey. This survey is really the best way for us to gather and evaluate feedback consistently. So if you have any users or communities that would like to provide feedback, please provide the link to this survey.
Sandra, how many more slides do you have? Because I'm sure there's going to be a few questions.
I have maybe 2 more slides, and then we can have a questions before Fernando goes into his presentation.
Sounds good. I don't want to squeeze him either, so we're good.
Sounds good. Just going back to the main page, on the informational page in the red box, you can see the links to all the visualization page, the quick start video that we just listened to, the feedback Google form where people can provide their feedback, and also to the pilot technical report. And I just wanted to bring up the intention that the technical report really in detail describes information on what data is used to develop estimates for Volume 1 and Volume 2. It outlines the federal, state, and local gauge networks that we use to develop Volume 1 data, and identifies the downscale data set that inform the development of pilot data set, but also the data sets that we're planning to use for the Atlas 15 CONUS release. It also describes the non-stationary statistical method based on maximum likelihood approach that is applied both on Volume 1 and Volume 2 data. As well, it explains in detail, there's at least 12 pages of how the regionalization and interpolation techniques was calculated for Volume 1 data. And here in a slide, I'm showing just an example of regionalization for Volume 1 information and how the data was weighted based on geographic and meteorological characteristics. It provides really details on how adjustment factors were calculated under the 2 distinct frameworks for Volume 2 data. And in addition, and I haven't listed it here in the slide, provides comparison between stationary and non-stationary estimates using Atlas 15 approach, and then how it compares to NOAA Atlas 14 approach. So in summary, Atlas 15 pilot is provisional information. We are providing a first look at the structure of a NOAA Atlas 15 dataset in order to collect early feedback on the development framework and web dissemination strategies. And as a result of feedback that we will receive, we will refine both methods, data, and website through 2026 and 2027 when we plan to release the NOAA Atlas 15 estimates over CONUS and OCONUS region. Here on the slide, I'm also showing example from documentation. These are spatial patterns for 60 minutes and 24-hour minutes for 1% annual exceedance probabilities for year 2023, which is volume 1 present day, and then 2 possibilities for volume 2 under global warming level 3 and 5. With that, that is my last slide. I just also wanted to mention here that if anyone has any questions or comments or need further clarification aside of this presentation today, we have our email atlas15.info@noaa.gov that you can send us an email. With that, I want to stop here and ask if there are any questions.
Yeah, thank you, Sandra. I want to make sure that we don't shortchange Fernando. So I'm thinking like maybe 1 or 2 questions. Does anybody have something that they want to mention or ask? Joe?
Just really quick. So I was in a jury in a case between 2 civil parties, and a licensed engineer actually took NCI data and applied Atlas 14, the static data sets, and both parties agreed to that. And so this is more of a question not just for the Atlas 15 folks, but also for the engineering community. When you can choose between volume 1, volume 2, and the various projections, how would that happen in the future? Because you could choose multiple cases with the same data, depending on whether so this is more of a pragmatic engineering practice question, and perhaps this is being answered in the future conditions chapter, or it can be thought about, but this introduces multiple answers. If someone just chose to use static, that's one answer. And if they choose a different one, they could have a different answer for the same location for that. So just, I bring it up because that's what we're looking at for the future from a information we're providing and what practice will say is the right answer in that particular case.
Anybody want to respond to Joe's?
Well, I can start, and then oh, I saw Don just put his camera on too. And Joe, that those kinds of things are prescribed in the standard, in the loading standard, what you're using. And then if you're going above code or you're going to something a little different than that, you know, those kinds of things would have to be documented. But the purpose of our future conditions is to provide a requirement, let's say, for that future condition that is defined in the standard. So you don't just choose anything you want, you have to choose this one if that's what you're going for using the design documents, let's say, at least for ASCE 7 design documents. I mean, when we go and tell them to look at, in fact, we don't have any data prescribed in ASCE 7 for rain. I mean, the Atlas 14 is even in the commentary. We don't have that directly. A lot of jurisdictions require you to use a certain, you know, a certain amount for their jurisdiction based on what they prefer. So the jurisdiction always overrules, but the design standards will tell you what to use in those, at least for building design, not for stormwater and things like that, but for building design, that's what it would do. So I have to qualify that, but.
All right, good. Any other question? I guess just along those stormwater. Oh, go ahead, Don.
Thanks, Dan. My question is, I was looking at the durations that was given on the Atlas 15 and ASCE 7, the one that Jennifer was just describing. We prescribe a 15-minute duration. I didn't see that on the list of options, which is and I know on other work that has come out of the Atlas stuff, they provided the 15-minute duration. Is that going to be provided?
Yes, Don, that's a great question. So yes, we are planning to provide the same duration and exceedance probabilities that we currently have in NOAA Atlas 14, which goes from 5 minutes to 60 days and up to 0.1 exceedance probabilities. For the pilot, we are providing just a subset to get the feedback, and that feedback then impacts the further development of Atlas 15.
Excellent.
Okay.
That was my
Thanks.
question, Don, so good job. That was exactly what I was going to ask. All right, thank you so much. All right, then Fernando, we're going to turn it over to you. And you've got about 15 minutes, but I'd like to try to have some questions. So Fernando, we're in your hands.
All right, I'll try to go fast, and if there's a particular topic that I can follow up on in a future meeting, happy to do that. So no problem at all with that. Okay, you guys can see my slides?
Yes.
Okay, perfect. All right, so apart from supporting the generation of precipitation frequency data, our office, that being the Office of Water Prediction, we lead in the development of freshwater prediction capabilities within the National Weather Service, and we do that in collaboration with other NOAA line offices. And then we support our field offices with operations, starting with our 13 regional river forecast centers across the country, and then our 144 weather forecast offices that are also spread across the country, which are the ones that actually issue flood warnings and watches and the actual operational products that go out to door, reach your cell phone, things like that. So that is what our mission is driven by, and we do that in collaboration with many different entities. There's a lot of activity concentrated at the National Water Center down in Tuscaloosa, Alabama, which is also where the USGS just opened their new hydrologic instrumentation facility just down the street from us. So lots of collaboration opportunities with the GS, but really the Water Center as a whole is a collaborative facility across NOAA, Army Corps of Engineers, USGS, and FEMA. It's really the instantiation of the IRIS consortium. Okay, so a lot of what we do day to day is supported by user-driven requirements that we've been conducting over the past decade and more. And as a result, an outcome of those engagements, it's become really clear that some of the things that keep people up at night are issues that relate to flooding or drought, water quality, water availability, and also climate change. And so we primarily focus on supporting these type of use cases. And really over the last 5 to 10 years, we've spent a considerable amount of time focusing on the flood use case, but certainly want to support all of these things. Okay, so as it relates to flooding, so within the Weather Service, right, we've been providing flood warnings, flood watches and warnings, and flood forecasts for a long period of time. And we've done that primarily through flood forecasts that come at 3,600 locations across the country that are supported by our regional river forecast centers. And these forecasts come in the form of hydrographs, and those hydrographs have various different flood levels identified. And for those flood levels, there's also what are called flood impact statements, which is what you see at the bottom of the screen. And those impact statements describe what the potential impact is if the water were to rise to that level. However, on the right-hand side, you'll see kind of an image that kind of speaks to the limited coverage of that flood impact statements relative to what the actual flood may be kind of evolving to, really impacting entire neighborhoods, not just one particular road or one particular plot of land or something like that. So there's been a spatial gap there that we're wanting to address, and that's what we've been focusing on over the last 5 to 10 years. Also, working with our partners at about 200 or so locations, in addition to having those flood forecasts, we've also developed detailed, you could say, engineering scale flood inundation map libraries that do allow individuals to go into a site and at a particular location, look at what the flood impact would be in map form, not only looking at extent and depth, really across a whole range of flows and stages. And so that's been really helpful for these locations. However, again, it's only at 200 locations, and then it's really only for a few miles of river at a time. So again, it doesn't really cover the entire country. And so that's another kind of spatial gap that we've been pushing on addressing. Back in 2016, Apart from the forecasts that come from our river forecast centers, we also implemented what's called the National Water Model, which is an operational hydrologic forecasting model that provides predictions of the various different phases of the water cycle, and that does that operationally. So, it runs 24 hours a day, 7 days a week, all throughout the year. And so the water model provides information that's there to complement the forecast from the river forecast centers. It really helps us, though, provide guidance in addition to the 3,600 locations, but really now spanning, almost 3.6 million river miles across the country as it relates to stream flow. Since 2016, we've evolved the water model. We've enhanced it and implemented, I think, 6 or 7 different version upgrades. We're currently in those version upgrades that's focused on expanding the domain, such as lower parts of Alaska, Hawaii, Puerto Rico, and the U.S. Virgin Islands. We've also worked on implementing more sophisticated hydraulic schemes and other things as well that have been fully documented. But right now we're at water model version 3. We do anticipate a version 3.1 being implemented late in 2025. And then we will be pushing water model version 4 sometime in 2026 or 2027. Water model version 4 will really have a completely new engine underneath the hood, which if I have time, I'll speak a little bit more about. Okay, so operationally, the water model has various different configurations. There's an analysis configuration, which is somewhat like a nowcast, kind of providing what the conditions are right now. There's also a short-range forecast that updates every single hour. That goes out 18 hours. And I think every 6 hours, it'll go out 36 hours. There's also an ensemble medium-range forecast, which updates every 6 hours and has 7 different ensemble members. And then there's a long-range forecast, which goes out 30 days and updates once a day and has 16 different ensemble members included. Those configurations are slightly different for the OCONUS domains like Hawaii and Puerto Rico and Alaska, but they are similar in nature. I forgot to mention Water Model version 3, apart from expanding the domain to Alaska, it also for the first time implemented a total water level capability where we're actually doing coupling with some of the coastal models and solving for the water surface elevation in that coastal zone. In addition to the water model and our deterministic forecast from the river forecast centers, we also have the hydrologic ensemble forecast system, which is a non-deterministic forecast at our 3,600 river forecast points. And those help provide the uncertainty of the forecast and help support reservoir operations and more, and kind of working to optimize the best use of our water resources. I won't go into too much detail about that. Okay, so with the advent of the water model, we had a continental scale hydrologic prediction system. So we also wanted to build a continental scale flood mapping system. And certainly with all the effort that's been invested in the FEMA flood mapping program, we kind of looked at this as starting to look at, okay, how can we leverage all of that modeling and expertise to build this continental scale system, but soon realized that the devil's in the details, right? If you look at all these cross sections from all these different RAS models, it's hard to bring it all together as kind of a first cut, right? You've got cross sections that are not necessarily evenly spaced, that are crossing over each other, and the density is different depending on where you look. So, of course, we've got floodplains, and we know that the floodplains are very much influenced by the terrain. And so we thought, well, maybe we can just take a different look at this and start working with terrain data and see if we can come up with a baseline approximate solution as a first cut, and then circle back to all this expertise that's already been invested in. Okay, so we've been what we've been doing since 2016 is working to implement a method called HAND, or height above nearest drainage. And essentially it translates your terrain model into a relative elevation model where all the pixels are now the relative elevation above the channel that it's draining to. And so using that relative elevation model, one can make some assumptions to derive synthetic rating curves and then actually build a continental scale mapping system from that. So this is just a quick snapshot of a hand grid for the entire country, leveraging 10-meter national elevation data from the USGS and having that support a flood mapping system. Sorry, I'm going fast, but the whole idea here is to be able to build a common operating picture for water prediction so that we can quickly look at the entire country, see where there's potential flooding going to happen, and then zoom into particular areas and see detailed inundation map forecasts to help support our emergency responders and communities. Okay, so we've been demonstrating this since 2016, 27 as outcomes of an experiment. We then worked across Texas and parts of the Northeast as part of what are called DOC NOAA agency priority goals to demonstrate this in near real time, how this could get implemented, as well as hosting a suite of tabletop exercises with emergency responders and other stakeholders to help kind of validate and give us feedback on how we could evolve this capability. And now we're starting to operationally implement this. We started doing that last year by publicly releasing these forecast flood inundation mapping services for 10% of the US population. A couple months ago in September, we expanded that public access to about 30% of the US population. And then over the next couple of years, we'll work on getting to nearly 100% towards an fully operational implementation. So this is the map of what that kind of rollout looks like. Again, the green and the blue areas are what are publicly available today. So if you go to water.noaa.gov or our new website called NWIPS, the National Water Prediction Service, and if you toggle the flood inundation mapping on the table of contents on the right, you will be able to see real-time flood map forecasts when you zoom into various different neighborhoods, at least for the areas that are already public. And again, we'll work to expand that over the next couple of years. Looking at the time, maybe that's a kind of good place to stop. And then I can dive into some more details maybe in a future meeting. But happy to answer or field any questions that you all have.
All right, Fernando, thank you. I really appreciate that. Questions for Fernando? I'm happy to give us another few minutes here. I guess, John, are you still on? What's the implications of all this work for, the work of the federal effort to map floodplain? How do these things link together, or do they?
They're supposed to link together. I know the Federal Flood Risk Management, the Future Flood Risk Data Initiative that FEMA is in the midst of. They're working side by side with the Army Corps of Engineers, and in that process, I know they interact with NOAA scientists, as well as I think NASA and DoD. So putting the best information forward for the more comprehensive depiction of flood hazard and flood risk. That's the effort, and FEMA is partnering, engaging, and learning, wherever advancements are being made to better depict future conditions from which, multiple practitioners can use the data, the design and construction industry, the standards development organizations, and the practitioners as well. So I don't have the specific example of what we're seeing here, but I know, if we're not making the right connections, I certainly can ask that team to react to this, or to be open to receiving a briefing or presentation.
Yeah, John, and if I could add, I didn't mention this just in the due to time, but one thing. So at the beginning, I said that we started first looking at what's been heavily invested in to support the National Flood Hazard Layer and all the modeling that's come out of that. We started with this baseline solution that's more approximate in nature, leveraging this hand capability. But now, through what we're calling the next generation water prediction capability, we did establish a data sharing agreement between our office and FEMA, and also one of our contractor Raytheon in Dewberry, to start essentially mining the entire MIP to extract out as many of those RAS models as possible, and then essentially building libraries from all of those existing RAS models so that we can implement in real time the outputs from the RAS mapping, so that where we have that, we've got a RAS-derived inundation map forecast, and then where we don't have that, we just have kind of the more approximate hand-derived inundation map. So that's one way that these efforts are coming together, so that we're kind of best able to leverage, right, this data and science that spans multiple of our agencies.
Absolutely, and you know, as you mentioned, and with the FFRD, it's not just the data for, you know, future development, because the FFRD is going to be equipped with a national structure inventory. So things like real-time inundation mapping and loss and risk assessments. You know, that's the goal for the utility of that platform as well. So the products that you're showing definitely support that application.
All right, any other questions? Fernando, thank you so much. Sandra, you too. You know, this work is so central to what we're working on. I apologize that we had to kind of rush you there, Fernando, but I think we've kind of laid a foundation that we can come back to and talk about more as things progress.